whenever you are using light sensors, a major consideration is your lighting environment. If that changes dramatically, if you go indoors versus outdoors, if you are practicing at your home versus the actual competition, the lighting conditions are going to be different. Now, in general, the NXT the LEGO light sensor does a fairly good job of returning similar values in a range of conditions. I've had line following programs that work just fine in dark and with the lights all the way turned up and a flashlight pointed at it, without changing a single thing. However, that's not to say that it is a variable that can be ignored. It is important to account for it. So in this video, I'm going to demonstrate a very, very small, very small and simple compared to some of the other things I'm showing, program that lets you save a file to your NXT for later use. This file contains an average value between what you expect to be the black line and what you expect to be the brightest thing near the black line. That is, the darkest thing that is not the black line near it. Also just called the dark and the white, even though in this case, as I'm going to explain throughout the video, you don't necessarily want to concern yourself with the actual white. You're going to care more about the blue or other colors on the board. Now, light sensors are, however, pretty dependent upon how far off the ground they are. It changes a number of things about their operation. So in here, we're going to use a attached touch sensor. Now, I'm assuming that this touch sensor is going to be just unattached to the robot that you're going to be using, like an old-style camera trigger. So over here, say touch sensor 1, wait until pressed. Wait until bumped. I'm also going to put up a display that is going to inform me what I am expected to do. It's going to simply say place on black. So we're going to place the NXT on our black values. Place both of the light sensors over black first. Now the nifty thing about this is that during your 1 minute setup period, you can run this program. Then if all of your other programs are configured to use that file that this program creates, all of your programs are configured in one fell swoop. And you don't have to worry about reprogramming your robot at all, simply in calibrating it right there. I should note that this does not use the NXT a built-in light sensor calibration, and for all these examples I'm doing so far, I've been using the intensity. When I teach my kids, I have them use the raw value instead. You can use either the intensity or raw value, whatever suits you. I vastly prefer the raw value because no matter what the setting on, no matter what the calibration of your light sensors are, it's going to be the same for both. Allow me to restate that. If you calibrate your light sensors for the one on port 3, it's going to calibrate both of them. Again, if you try and calibrate it for port 2, it's going to undo that calibration for the for the port 3 light sensor. So raw value is consistent no matter which one is calibrated. That's what I meant to say. However, in this video, I'm just going to be using intensity for consistency with my previous videos, because with raw value, the lower values indicate brighter values. A value of 1023, the maximum possible value you can return, is going to indicate pure black, while a value of 0 indicates pure light. Alright, so moving back over here. Let's say that port 3. Now I don't actually need to use variables here, but it helps my sensibilities. So I'm going to say black is a number, and I'm going to write the intensity into black. I could have used wires and dried them all over the place, but I do kind of prefer using variables, even though it clutters things up. So wait. Now, why not? I'll have it play a tone to indicate that it has found that it has actually received my input. So it's going to wait for completion as well. I'm going to do the same thing, except it says place on white. Now I'm going to put quotes around that, because placing it on white is not technically correct. It's not actually what we're caring about. Because if white has a value of, say, and I'm exaggerating here, white has a value of 100, and black has a value of 0. If the blue has a value of 40, it will be read as black. Now, that can be very, very bad, because you do not want your line follower to try and follow the blue water aspect of the board. That would be very disastrous. Okay, over here, oh, I've also had a major oversight. I am simply going to average my two light sensors and place them into a single variable. Now, of course, to average two things, you add them together and then divide by 2. I thought that was looking a little small. So here, I connect light sensors 3 and 2, I add them, and then I divide them by 2. Since averaging two things seems like something I'll need to do, more than once, I will turn it into a my block, and I will call it AVG. Now, of course, I've already made one called average, so I will add in redux just to indicate that this is a new my block. Whoops. Of course, you're going to want an output, so make sure that you have that wire leading out as well. The wires at the time of when you click the my block are what matter. Alright, so that's getting stored into black. Now I can copy all of this over here and tell it to place it on white. Of course, here I'm going to want to use a different variable. And ultimately, I'm going to want to read out of these two variables, average them together, and I want to write them to a file. Now, when you deal with files, you have to be careful. If you write to a file, it adds it to the end of the file. It appends it. It does not change the file to be simply that value, which is actually what I want to accomplish here. I want it to be only this one value. So what I'm going to do is I'm going to delete that file. I have a habit of going ahead and making sure that I close things all the time. You'll notice that in my earlier video I did not do that. I did not close this file even after I accessed it. I did not close it beforehand either. Usually what I will do is I will say close it at the beginning of the program and also at the end. This is simply to ensure that I play nice with the rest of my programs at large. And I don't know if you can have multiple files open or not. I only ever deal with one. Alright, so now the result is ultimately going to be written over here. Now, all of these I want to be set to light threshold, and I'm just going to find it easier to control, click and drag that over rather than retyping that. Yes, okay. And of course this needs to write a number. Now I make sure that I close it, and just because I may be curious, I'm going to go ahead and write the number to text, and then display that for 3 seconds. Now you'll notice there's no switches, there's no control loops in here, there's nothing fancy. This is actually a very straightforward program. There's not a lot of complicated logic to follow, even though, because of the way that the NXT programming environment works, it looks very long. I'm actually only accomplishing just a couple of things. This is one of the drawbacks of this this form of NXT programming, is that it is hard to see what you're doing all on one page, so you have to keep it in your head. Whoops, that's not what I wanted. I'm going to want to wait for, let's say 5 seconds before I go ahead and exit out of this program. Now, this has no need of being a mod block, since it will be run once. It will never be run inside of another program, so I'm simply going to go File, Save As, and call this Calibrate, well, lightThreshold. I think that's a slightly more appropriate name. Alright, and my following videos should indicate how all of these work in combination. And since I haven't tested any of these yet, contain any bug fixes that I may need to be made, fixing the errors I may have made in the course of these last few videos. Thank you for watching.